All right, good morning. All right, I want to apologize for what happened last time. I actually thought it was a problem on my end, but it wasn't. I got an email later from the district saying that it was a technical problem. So I was like, it's been nice if they had told me right away instead of me spending 2 hours trying to figure out if it was my problem. It wasn't. So anyhow, I hope you were able to watch the YouTube video because I'm not going to teach the lesson. Because remember, I have 2 pre-calculus classes. So if somebody gets the lesson and a class doesn't get the lesson, you have to watch the video because the classes cannot be out of sync. Things are already hard enough as it is. So I can't be teaching lesson 1, 2 on one in one period and lesson 1, 3 in another period. And then in another period, it just doesn't work that way. So I'm just letting you know if there's ever any technical difficulties like that. I worked real hard to get that video up on YouTube. And so if you haven't watched it, you're in trouble. You gotta watch it because I'm not gonna teach the lesson today. The lesson is on my YouTube channel. So if you haven't watched it, you have double the work to do. Also, this assignment is due tomorrow night. So I'm gonna finish 1.3 and it will be due tomorrow night at 11:59. In addition to that, we're going to have an exam on 1.1 through 1.3 on Friday morning at 8 o'clock. So the assignment 1.3 is due tomorrow night, and we're going to have an exam 1.1 through 1.3 at 8 o'clock on Friday morning. I just want to take this opportunity to say that we are almost in the month of November, and December is the end of the semester. I'm not going to be doing a whole lot in December trying to get students caught up on things or whatever. So you need to take responsibility if you want to pass this class to meet with me. There were some problems at the beginning. People were missing things and missing exams. Yeah, unless you meet with me, I'm going to think you don't care and you're going to get the grade that you get. So I do believe in giving students a chance. Because I don't want students to ever think that it's a hopeless situation. You know, why should I do anything right now? Because I have a 32%. I never want students to think, oh, you know, why should I even try because I can't pass the class. There is always an opportunity to pass the class, but you have to talk to me so we have a plan. If you don't talk to me, then I'm just going to assume you don't care about the grade. So you have to make an effort to contact me. And we need to set up a plan, and you need to do that as soon as possible because, like I said, I'm not going to be doing that in December. So running out of time. So you got to get with it. Like I said, I'm going to finish the lesson today in 1.3. Those of you who watched the YouTube lesson, you're ready to go. Those of you who didn't, you need to watch it. But I talked about quite a few things last time. I spent almost the whole time teaching about increasing, decreasing, and constant. I also talked about maximum minimums. I also talked about symmetry. If you test out a function and it's even, that means y-axis symmetry. If you test out a function and the points are exactly opposite, that's odd, and that means origin symmetry. So I talked about all this. And we also talked about domain, range, x-intercepts, y-intercepts, increasing, decreasing, constant, maximum, minimum, evaluating a function at x. So make sure you watch the lesson. I'm going to start today on page 197, problem number 53, and I'm going to do problem number 54. In this section, we're talking about piecewise functions. This is brand new. A function means it passes the vertical line test, and piecewise means it's pieces of functions. So for example, in this, we're not going to be graphing these, we're evaluating it. In the next section, you'll have to graph. So the hardest thing about this is just understanding what you're looking at. So I'm going to explain that. Can you mute yourself, please? All right. So here, there's two functions here, and there could be 3 or 4. So this is y equals a line and y equals a line. So it's 2 different lines. And this stuff over here is the domain. So the first line only exists to the left of 0. And the second line only exists to the right of and including 0. So these are all the solutions less than 0, and these are all the solutions greater than or equal to 0. So I'm going to show you how to graph these in a moment, but right now we're evaluating. So what you do is, and we've talked about this, this is x, when x is -3, this is y. So where does -3 fit in? Is -3 less than 0? Is -3 greater than or equal to 0? It's not going to work in both. It's only going to work in one of them. So where does it work? Does it work here? -3 is less than 0, or -3 is greater than or equal to 0? All right, I'll ask you again. Is -3 less than 0, or is -3 greater than or equal to 0?
Less than 0.
It's less than 0.
So that means you're using the first function. So what this means, -3 works in the first function. So now we're going to evaluate when x is -3 to get y. So wherever you see an x, you put a -3. So this is 6 times -3 is -18 minus 1 is -19. So when x is -3, y is -19. And this f of -3 also represents y. So y is equal to -19. So basically, this is a fancy way of writing an ordered pair, but we're not writing ordered pairs. We're evaluating when x is -3, y is -19. So let's go to B. Now B could work in the same one again, or it could work in the second one, or it could work in the first one. All these problems could work in the, you don't have to do both. They can work in one or the other, or you could keep working in the top one. 54. B is f of 0. So where does x fit in when it's 0? Is 0 less than 0, or is 0 greater than or equal to 0?
Greater or equal to?
Right. So you write down the function where it works, which is the second one, and you put in 0 to evaluate. So this would be 7 times 0 plus 3 is 0 plus 3 is 3. And finally, in 54C, they want us to evaluate f of 4. Now, where does 4 fit? Is 4 less than 0, or is 4 greater than or equal to 0?
Greater than or equal to?
Right. So we're going to use the second one again. So now we're going to evaluate f of 4, which would be 7 times 4 plus 3, which is 28 plus 3, which is 31. So when x is 4, y is f of 4 is equal to 31. So this is evaluating piecewise function. In a minute, we're going to graph these. So we're going to graph these two lines and restrict the domain and graph them. Right now, we're just evaluating. Evaluate means find a number. Solve means find the variable. So what does evaluate mean? What does solve mean? Solve means what? Solve means find the variable. Evaluate means find a number. What does evaluate mean?
Number.
What's solve mean?
Evaluate the variable.
Find the variable. Let's do another one of these. Let's do 57. Actually, I assigned that one, so let's do 58. So you have an H function, it's a piecewise function, which is more than one function. This one is x squared minus 25 divided by x minus 5. That's a rational function. And y equals 10 is a horizontal line through the y-axis at 10. Okay, now there's a restriction on the domain of these. So the first one says that it exists if x does not equal 5. So as long as x doesn't equal 5, it exists. And the other one, x can only equal 5. So in 58A, they want you to evaluate h of 7. So is 7 not equal to 5, or is 7 equal to 5? So you're looking at the domain. Is 7 not equal to 5, or is 7 equal to 5? Which one does it work in?
Not equal to.
The first one, right? 7 does not equal 5.
Mm-hmm.
So you have h of x is equal to x squared minus 25 over x minus 5, and you put in a 7. So this would be 7 squared minus 25 over 7 minus 5. So 7 times 7 is 49 minus 25 over 2. Can you guys see this? I'm just going to write over here. So this would be 49 minus 25 is that 24? 49 minus 25 is 24 divided by 2, which is 12. So in B, they want us to evaluate h of 0. So where does it belong? Is 0 not equal to 5, or is 0 equal to 5?
Not equal to 5.
Right. So we use the same one again. And we evaluate when x is 0. So this would be 0 squared minus 25 over 0 minus 5, which is negative 25 over a negative 5. A negative divided by a negative is a positive 5. Okay, we'll do one more, which is C. They want us to evaluate h of 5. Now, is 5 not equal to 5, or is 5 equal to 5?
It's equal to.
So it's just, so the function is a horizontal line. So when you put in a 5, no matter what x you put in, you're going to get 10. There's no variable. So no matter what x you put in to the second one, you're going to get 10. Okay, now all of this is evaluating, which means find a number of these piecewise functions. And what you're focused on is where does the x exist in the domain, and that's what equation you use. Okay, anybody have a question before we go on? It's pretty easy if you understand what you're looking at. You're looking at two functions, and these are restrictions on the domain for each one of them. Okay. So now we're going to look at graphing piecewise function and finding the range. So I want to do problem number 60. And it's f of x. It's a piecewise function again. And that's a linear function, and that's a linear function also. And this domain it exists less than 0, and this domain is greater than or equal to 0. So see how the entire domain is covered? Now, when you look at these problems, if you have a quadratic or cubic, use transformations. When you have a line, use slope-intercept form. So this one is, this one's y is equal to 1x plus 0 in slope-intercept form. And the other one is y is equal to negative 1x plus 0 in slope-intercept form. So remember how we graph these? The slope would be up one, right one, up one, right one, or down one, left one, down one or left one, and the y-intercept is 0, 0. On the second one, if we were to graph it, the slope would be down one, right one, down one, right one, or up one, left one, and the intercept is 0, 0. So now I'm going to graph these. So the first one, the intercept is 0, 0, and I'm going to go up one, right one, up one, right one, up one, right one, up one, right one, or down one, left one, down one, left one, and draw the line. Now, this line doesn't exist everywhere. It only exists to the left of 0. So this is x is equal to 0, right? It only exists to the left of 0. That means that everything to the right has to be erased. And since that's strictly less than, you have to open it at 0. So now you look at this and go, okay, the graph only exists to the left of 0? Yes. So the graph only exists to the left of 0. So now we do this one. Now its intercept is also a 0, 0, and we're going to go up one, left one, up one, left one, or down one, right one, down one, right one. When we draw this, see how it fails the vertical line test? So it's no longer a function. This red one only exists to the right of 0. So this should be closed, and it exists only to the right of 0, which means everything to the left has to be erased. So that's what your piecewise function looks like. The black one is the first one, the red one is the second one, and you can do the vertical line test, and it does pass the vertical line test. So this guy was open on 0, this guy was closed. It's a function, passes the vertical line test. So you're drawing pieces of graphs that create a function that passes the vertical line test. And what you're doing is you're restricting the domain on each function to create a piecewise function. Okay, now they want the range on this. So the range, remember the range is where the graph exists up and down. So this graph goes down forever and up to 0 closed. And that they wanted the range in part B. So in part A, they want the graph. And in part B, they want the range. Now you must show this work by hand on an exam. You cannot use a calculator. If you use a calculator, I'll mark it wrong. You have to show me that you can graph. Okay, I'm going to do a harder one with a quadratic. Do you want to ask me about anything on this before I erase it? All right, let's do problem number 68. So on 68, we have a function, and it is a piecewise function. And the first part is -1/2 x squared. So that is a quadratic that's been vertically compressed by 1/2 and reflected over the x-axis. And the other one is a linear function. So the domain for the first one is all the x is less than 1. So the solutions are less than 1, the x's are less than 1, or the graph exists to the left of 1. And the second graph exists to the right of and including 1. So I'm going to do the first graph in black and the second graph in red. So the first graph, like I said, I'm going to use transformations on a quadratic. So what is this in the right order? It would be a vertical compression by 1/2, and you're reflecting over the x-axis in that order. So remember the points of the parabola are left one, up one, 0, 0, right one, up one. And so a vertical compression by 1/2, you multiply the y by 1/2, the x's stay the same. So multiply by 1/2, multiply by 1/2, multiply by 1/2. And now, remember this movement, reflect over the x-axis is a vertical movement. So you're going to multiply the y, you're going to negate it. So negate the y, negate the y, negate the y, and now we're ready to graph using transformations. So this would be, hold on a minute. So this would be left one, down 1/2. This would be 0, 0. This would be right one, down 1/2. And so your parabola looks like that. But it only exists to the left of 1. Now don't look at the y's, you're looking at the x's. So at 1, it has to be open, and everything to the right has to be erased. So this is the parabola, and it only exists to the left of 1. Okay? Okay, so now we look at the line. Slope-intercept form. The slope would be up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. Those are equivalent. The intercept is 0, up 1. So we go 0, up 1, and we go up 2, right 1, up 2, right 1, or down 2, left 1, and you draw the line. So it's like 2 different graphs. It's like having two different graphs and you're superimposing them on each other. So I have a black graph and I have a red graph and I'm putting them on top of each other. So this graph goes like this, right? But this graph only exists to the right of it, including 1. So that means everything to the left has to be erased. So I kind of messed this up. So see that? See how it's open on the quadratic, but it's closed on the line, and it only exists to the right. So see how it is a function, and it passes the vertical line test? And this one's open, that one's closed, so it passes it. So just a reminder, if you have greater than or less than, you keep it open. It means it's not included. If you have greater than or equal to or less than or equal to, it means it's included and has to be closed. So now they want the range. Well, that doesn't work. Where does the range exist? Well, it's in 2 parts, isn't it? So doesn't it exist from -infinity up to 0 closed? Or isn't that 3 up forever? So I'm going to check this, but isn't that where you see the graph? Yes, that's correct. So the range, remember, is up and down. So you see the graph from -infinity up to 0 closed, or closed on 3 up forever. Okay, now go ahead, I'll take questions. These are graphing piecewise functions. You cannot use a calculator. You must use transformations. On higher degree polynomials on lines, you're going to graph using slope-intercept form.
So we still use both equations?
It could be mixed up. It could be 2 quadratics. It could be a circle and a cubic. It could be 2 lines. It could be a quadratic and a line. It just depends what they give you.
All right.
It could be anything. You just have to look at it and go, oh, that's a quadratic. I'm going to use transformations, and you have to know the order. Oh, that's a line. I'm going to use slope-intercept form. So you have to be able to look at it at the piecewise function, know what it is. Is it a quadratic? Is it a cubic? Is it absolute value? Is it square root? What is it? So that you know how to graph. Any questions? Does everybody see that the black graph exists to the left of 1 and the red graph exists to the right of and including 1? The range, you're looking up and down. This is the domain where the graph exists left and right. Okay, last call. Anybody want to ask me about anything? All right, I have one more thing to teach, and then we're going to get in the teams. What I'm going to teach right now has something to do with calculus. It's too much for me to explain, but I'll try to tell you a little bit what's going on. See, in Algebra 1, we focus on linear functions, which are lines. And now with the Common Core State Standards, we're focusing on quadratics in Algebra 1. Now with you guys, I went over quadratics. I did not assume that you knew it. I also went over linear. But we only know how to find slope on a line. In calculus, we want to be able to find the slope between 2 points on a curve. And that's why calculus in real life is so important, because everything in our life is not a straight line. everything's curved. So it's important to know the slope between two lines on a curve. So that's enough. And by the way, that slope in calculus is called the derivative. Okay. So part of this process is called the difference quotient. And they're introducing it to you right now, just to familiarize you with it. And let me show you what it looks. Difference means subtract. And quotient means divide. So let me show you what this looks like. It looks like f of x plus h minus f of x divided by h. So that's the difference quotient. And h cannot be 0 because you can't have a 0 in the denominator. So I'm going to try to organize this and try to make this very clear about what to do. So I'm going to look at problem number 72. And it says that our function is 7x. So this f of x is going to go there. So we're going to take that out in a minute and put a 7 in there. But we want to know this, what is this f of x plus h? Well, remember earlier when we were evaluating, we did the same thing. It's easy. Wherever you see, it's an x. Wherever you see an x, you're going to put x plus h. So you just go, okay, this is going to be 7 times x plus h. So all I did was put x plus h in for x. So f of x plus h then, when you distribute, is 7x plus 7h. So I think we're ready to do the problem. So the problem says, take f of x plus h, which we found to be 7x plus 7h, and subtract the function and put it over h. So once again, we took f of x plus h and subtracted the function and put it over h. So what happens is these guys cancel. We get 7h over h, and so our answer is 7 for the difference quotient. And unfortunately, you won't see the value of that number until you learn how to do limits, and you will see what that number actually represents. Okay, we're going to do another one. Just make sure you have it written down. So all we're doing is we're evaluating the difference quotient. So let's do problem number 78. So 78 is a quadratic, so it's going to be a little more difficult. And they're saying that the function is x squared minus 5x plus 8. So that's the function. It's going to go there. Now listen, when I put this in here, don't forget to put this in parentheses so you don't forget to distribute the negative. So when the function is a sum of terms like that, make sure you put it in parentheses. But before we do that, let's find out what f of x plus h is. So wherever you see an x in the function, you're going to put x plus h. So all I did was put x plus h in for x. Now, the reason why this is a mess is because we have to FOIL x plus h times x plus h, distribute negative 5x minus 5h plus 8. So when you FOIL, this would be first, outer would be hx, inner would be hx plus h squared minus 5x minus 5h plus 8. So two of those, 1 plus 1 is 2hx plus h squared minus 5x minus 5h plus 8. And guess what? Those are all unlike terms. None of them go together. So now we're ready to do the problem. So we take our f of x plus h, which is this. So this would be x squared plus 2hx plus h squared minus 5x minus 5h plus 8, and subtract the function, which would be minus the quantity x squared minus 5x plus 8, and divide by h. So that first part is f of x plus h minus the function over h. So all I did was I took this information and put it into the quotient, difference quotient. Okay, here we go. So I'm going to distribute that negative. So you get x squared plus 2hx plus h squared minus 5x minus 5h plus 8 minus x squared plus 5x minus 8, all divided by h. And now there's always going to be things that cancel. If things don't cancel, you did something wrong. So this positive x squared cancels with the negative x squared. This negative 5x cancels with the positive 5x. And this positive 8 cancels with the negative 8. So what you have is you have 2hx plus h squared minus 5h, all divided by h. And what you should notice is you can divide everything by h. So another way you could take out, you could do a GCF and take out an h. So h times what is that? 2x. H times what is that? H. H times what is that? Negative 5. And you can cancel the h's. So your answer is 2x plus h minus 5. Let me just check the answer. 2x plus h minus 5. So that is the answer. So yeah, it's a lot of work, but it's not hard. It's stuff we've learned. You know how to FOIL, you know how to distribute, can't combine, there's no like terms here. Hx plus hx is 2hx. I'm putting them in alphabetical order. When you get to a certain point, a whole bunch of stuff's going to cancel, and then you end up with the answer to the difference quotient. Okay, now today in the Math Wizard teams, we are going to start on problem number 53 and do the assignment from 53 on. So supposedly you've done the assignment up to 53 because I taught that last time. So in your Math Wizard teams, you're going to start with evaluating a piecewise function. Then you're going to graph piecewise functions and state the range. And then you're going to find, you're going to find and simplify the difference quotient. Okay, so class is over at 12:10, so you got quite a bit of time. Yeah, so that's this lesson, part 1. Like I said, if you didn't watch it, you better watch it. You can't just be absent from class. So with us, with the technical problems with the district, we missed the lesson. So like I said, I uploaded it to YouTube, and it was your responsibility to watch it. And I told you, make sure you watch it. We're gonna spend, and then the other thing is, I have students that act like they're logged on, but they're off working or they're off playing Xbox. And I know that you're not there because when I talk to you, you don't answer me. And so I want you to know that really the only game you're playing is with yourself. And those of you who are doing that aren't getting very good grades. You're failing. So time is running out for you to straighten up. The other thing is some parents are saying, well, Bozo was in class. And I'm like, okay, hold on a second. That's my landline. Hold on just a second. Hopefully it's going to shut off. Okay. The parents are saying, Bozo was in class. And I'm like, yeah, they were in class 20 minutes. They didn't work 60 minutes in the wizard teams. So I'm asking the parents, you want me to mark them present? They were only in class for 20 minutes. You want me to mark them present? So I'm just letting you know, I'm not playing games with anyone right now. So I'm being very frank and very honest with the parents. So those of you who are messing around, I would get with it. You're running out of time. So, all right, I will see you in the Math Wizard teams. We are not checking back in classes over at 12:10, so you got quite a bit of time. You're going to start, this is lesson 1-3 on page 197. You're going to start with problem number 53. All right, I'll see you in the teams.